Look at this footage. A 2.5-ton supercar physically jumping off the tarmac from a dead stop. Now, look at this. The exact same vehicle driving perfectly straight at high speed, completely missing a front wheel. And this, a 3-ton luxury SUV floating in deep water, propelling itself and turning on its own axis like a tank. These are not CGI concepts. These are mass-produced vehicles from BYD, driving on public roads today. For decades, the West arrogantly laughed at the Chinese automotive industry. But while European titans like Porsche, Mercedes-Benz, and Bentley were busy polishing their leather and marketing their magic body control, BYD silently built a technology that just broke the laws of physics. They have rendered 140 years of Western chassis engineering completely obsolete. To understand how a company that started out making mobile phone batteries in Shenzhen just humiliated the legacy automakers, we must first expose a deeply ingrained lie. For over a century, the global car industry has sold you a fundamentally passive, reactive compromise. Strip away the heavy soundproofing and the polished wood veneers, and the core mechanical systems of a $100,000 European luxury saloon are functionally identical to a Victorian horse-drawn carriage. They rely on a steel spring to bear the static weight of the heavy vehicle, and an oil-filled tube, the damper, to stop that spring from oscillating indefinitely after hitting a bump. It is a system built on failure. When you hit a pothole, the wheel is violently forced upwards. That kinetic energy forces hydraulic fluid through tiny, restrictive valves inside the damper. Because fluid possesses physical viscosity, this creates an unavoidable mechanical lag, known in engineering circles as hysteresis. Even in a modern, highly advanced European performance car, the suspension takes time to react because it is permanently shackled by this physical delay. You are paying for technology that is inherently too slow for the road. For decades, chassis engineers in Europe and Detroit have gaslighted the motoring public. They confidently claimed that this compromise between luxurious ride comfort and track-level precision was an unbreakable law of physics. They insisted you simply could not have a heavy saloon that rides like a hovercraft whilst cornering like a track car. But behind closed doors, they knew the solution existed. We must look back to the early 1990s. The Williams Formula One team, in a pursuit of aerodynamic perfection, built the legendary FW14B driven by Nigel Mansell. It utilized an active hydraulic suspension system that could physically control the ride height of the car at every corner independently. The car was so dominant, so much faster than anything Ferrari or McLaren could produce, that the FIA had to step in and ban the technology entirely for being double too effective. Around the same era, a brilliant acoustic engineer named Dr. Amar Bose, the man behind the famous audio company, spent over 30 years and hundreds of millions of dollars trying to adapt electromagnetic motors to replace traditional vehicle dampers. His secret, Project Sound, Lexus LS400 prototypes were astonishing. They could corner completely flat, without a single degree of body roll, and could literally jump over obstacles in the road. Yet, the legacy automotive industry killed the project. They looked at the technology and dismissed it, arguing it was too heavy, too complex, and critically, it drained too much electrical power from a standard 12-volt battery. They chose slow evolution over rapid revolution, betting their futures that the internal combustion engine and low-voltage systems would rule the roads forever. The Western automakers failed to predict the inevitable rise of the high-voltage electric vehicle platform. Now, BYD has picked up the exact engineering baton that the West so arrogantly dropped. By leveraging the immense electrical energy stored in modern EV battery packs, they have brought the linear motor suspension into mass production with their luxury saloon, the Yangwang U9, and its revolutionary DiSus-Z system. Let us be absolutely clear about what this technology is, because the automotive press often gets it wrong. This is not traditional air suspension. Air suspension merely replaces a metal steel spring with a slow, gas-filled rubber balloon. It is still governed by the sluggish movement of compressed air. The DiSus-Z system eliminates fluids and gases entirely. It is a completely dry system. At every single corner of the vehicle, sitting inside the wheel arch, is a three-phase linear electromagnetic motor. Imagine taking a high-speed maglev train track and wrapping it into a compact, highly pressurized cylinder. When the car's computer applies electrical current, it generates immediate force. It does not wait to build hydraulic pressure. It acts at the speed of light. The defining metric of this mechanical rupture is 10 milliseconds. That is the DiSus-Z system's reaction time. To put that staggering number into perspective, an average human blink takes about 100 milliseconds, and your brain requires up to 250 milliseconds just to process a visual threat on the road ahead. Utilizing an array of LiDAR scanners and advanced road reading sensors, the DiSus-Z calculates complex force vectors and physically moves the wheel 20 times faster than your brain can even register that a bump exists. This turns the legendary Amar skyhook theory into reality. The body of the car remains perfectly level, floating parallel to the horizon, whilst the heavy alloy wheels frantically articulate up and down below it, acting as if they are mechanically disconnected from the passenger cabin. The electromagnetic motor actively extends the wheel down into a pothole and retracts it before the kinetic shockwave has any time to transfer through the chassis. Myth naturally. Automotive purists and traditional engineers have long argued against placing heavy electric motors directly at the wheels. They argue that the unsprung mass ruins handling dynamics because a heavy wheel carries too much inertia to respond quickly to bumps. This is a valid argument, but only if you are talking about ancient, passive suspension systems. The DiSus-Z is fundamentally different. It is an active system, and crucially, it is powerful enough to manage its own immense weight. It can thrust the heavy wheel downwards faster than the natural acceleration of gravity, pushing it into the tarmac at over 9.81 meters per second squared. This forces the tire's contact patch deep into the asphalt, generating massive mechanical grip, where absolutely none existed a fraction of a second prior. The suspension literally acts as an active downforce generator. It creates a telepathic connection to the road surface that no conventional spring or damper setup, regardless of how meticulously tuned by European engineers, could ever hope to replicate. If the U7 saloon is the elegant, U-luxury implementation of this technology, the DiSus-X system, found in the Yangwang U9 supercar, is the weaponized brute force application. By taking full advantage of an 800-volt silicon carbide electrical architecture, the suspension system alone demands a peak power output of 36 kilowatts. Think about the sheer scale of that number. The suspension on this car consumes more raw electrical power than the entire drivetrain of a small European city car. This brute force is exactly what allows a vehicle weighing nearly 2.5 tons to physically jump all four wheels off the earth from a standstill. When the viral videos of this jump circulated online, many dismissed it as a cheap carnival trick or a marketing gimmick. They were wrong. It is an undeniable, terrifying demonstration of power density. Compare this 800-volt Sledgehammer to the current offerings from European rivals. The highly praised Porsche Panamera utilizes a 48-volt active anti-roll system. It is certainly a good system at twisting a metal bar to stop a car from rolling in a corner, but it cannot make the car jump, nor can it provide the three-wheel drive safety mechanism we discussed earlier. In the grand scheme of modern automotive engineering, the 48-volt architecture is simply a toy by comparison. BYD has brought a nuclear weapon to a knife fight, and the legacy manufacturers don't even realize they have lost yet. BYD did not stop at linear electromagnetic motors. The third, and perhaps most imposing pillar of this ecosystem is the DiSus-P system, which is engineered specifically for the massive Yangwang U9 luxury SUV. Because a vehicle of this size requires a different approach to physics, this system uses highly intelligent, computer-controlled hydraulics to deliver immense power and suspension travel, functionally destroying the off-road capabilities of the best vehicles from Toyota and Land Rover. The DiSus-P features concurrent 3-axis control and completely eliminates the need for mechanical anti-roll bars. On the smooth tarmac, it cross-links the hydraulic chambers across the axles to stiffen the vehicle by up to 200%, entirely eliminating the dreaded SUV wallow through fast corners. But when you take it off-road, it completely unlocks, allowing for a staggering 155 millimeters of independent wheel articulation. The true genius here, however, is extreme survival engineering. If the massive U8 accidentally enters deep water, it automatically triggers emergency float mode. The car instantly seals the body, shuts all intake vents, raises the suspension to its maximum height to reduce hydrodynamic drag, and uses the spinning wheels to propel and steer itself exactly like a boat. Because of its independent motor control, it can even perform a tank turn on its own axis. And if you suffer a puncture in the middle of a harsh desert, the hydraulic pumps are so overwhelmingly strong that the car will lift its own damaged wheel high into the air, allowing you to change the tire without ever needing a physical jack. It lifts its leg like a dog. This is not just luxury. This is military-grade utility wrapped in leather. Perhaps the most brilliant, yet least discussed, engineering feat of the DiSus architecture is the thermodynamic shift. Since the invention of the automobile, traditional dampers have been parasitic devices. They take the vertical kinetic energy of a car hitting a bump, turn it into heat, and wastefully dissipate it into the atmosphere. Because the DiSus-Z and X systems operate via powerful magnets moving rapidly through electrical coils, every single impact on the road surface actually induces an electrical current. The suspension is actively harvesting energy on rough surfaces and feeding it straight back into the high-voltage traction battery. This regenerative damping offsets the massive power consumption of the system, finally solving the efficiency issue that killed Dr. Bose's original project back in the 90s. The worse the road surface gets, the more energy the car recovers. It creates a symbiotic relationship with poor infrastructure that internal combustion engines simply cannot achieve. Culturally, this technological leap marks the death of the traditional chassis tuning guru. Brands like BMW M, Lotus, and Porsche have historically relied on master engineers, testing thousands of physical shims, springs, and rubber bushings for months on end just to find a car's soul. The DiSus system turns that mechanical soul into nothing more than lines of code. Rebound, roll stiffness, and dampening are now merely software variables. You can download an over-the-air update for a comfort mode that replicates the floaty ride of a 1970s Cadillac, or switch to a track mode that mimics the rigid spine of a GT3 race car. The physical hardware remains entirely untouched. We have definitively entered the era of the software-defined vehicle. For decades, the West arrogantly assumed that the Chinese automotive industry could only ever produce cheap imitation vehicles with poor driving dynamics and compromised safety. BYD's DiSus technology proves that era is violently over. They have innovated a system that renders legacy European chassis engineering entirely obsolete. For buyers in the US, the UK, Canada, and Australia, the question is no longer, is a Chinese car good enough? The hard, uncomfortable truth for 2026 is this: why on earth would you pay $100,000 for a German vehicle that is still relying on Victorian suspension technology? The revolution is silent, electric, and terrifyingly fast.